Well, it's my great pleasure to introduce Phil Windley as our keynote speaker today. And for a little background, I've known Phil for 20 years. That's hard to believe. So Phil and I came here to BYU in 1993 together as faculty. But let me give you a little background about Phil. In 1990, Phil earned a PhD in computer science from the University of California at Davis. He then served as a professor of computer science at the University of Idaho. Got really used to the cold, so he's functioned well in the last couple of days. He was then a professor of computer science at BYU, where we met. Shortly after that, he was the founder and chief technology officer of iMall Incorporated, which was later sold to Excited Home, where he became a vice president. After that endeavor, Phil served as the CIO for the state of Utah and served on Governor Leavitt's cabinet. He's the author of 2 books, The Live Web and Digital Identity. He currently serves as an adjunct faculty member in computer science here at BYU. He speaks often on event-driven architectures, web services, and identity, and we're lucky to have him here today because he was, I think, in California yesterday participating in such an event. He currently is involved with Kinetics Incorporated as a founder and chief technology officer. And how that's pertinent for our discussion today is Kinetics offers a cloud-based application platform that is uniquely architected to use events. I suspect that might come up today. I'd like to just mention, above all else, Phil is an amazingly intelligent individual of great faith. It's a pleasure to be Phil's friend, and it's a pleasure to introduce Dr. Windley today.
It's all right. I'm going to come up here so that I can see you better. Down there it's a little bit harder. Thanks, Kelly. That was a very generous introduction. He made up half of it, but I'll let you guess which half. So today I want to talk about trillion node networks. Now, a trillion is a big number. It's hard for us to imagine because our linear brains like to think of a billion as just bigger than a million, and a million and a trillion just bigger than a billion. But in fact, we all know that a billion is 1,000 times longer than a million. But what does that mean? Well, a million seconds is about 10 days. A billion seconds is about 30 years. A trillion seconds is 38,000 years. So a trillion is a really big number. Now put that in perspective of today's network. Today's network has somewhere between 2 and 3 billion people on it. It has more things than that on it. In fact, for the first time in history, several years ago, the number of things connected to the network surpassed the number of people who are on the network. So there's more than a few billion, but still we're talking about billions of things on the internet. A trillion node network is a much, much bigger thing. So when you think about a trillion node network, it's going to dwarf what we have now. It's going to be very different than what we have now. And so what I want to ask, the question I want to ask today is, what will such a network look like? Why will it come about, and how will it be accomplished? So let's talk first about why such a network might come about. You're all familiar with Moore's Law, the idea that computing power doubles roughly every 18 months. And to put that in perspective, today you can build a microprocessor with a Wi-Fi connection for around $30. In quantity, you can probably get it cheaper than that, but you could go just buy the parts now and get a microprocessor and put a Wi-Fi connection on it and spend $30 and have something that works pretty well. And we're all familiar with those kinds of things like the electric imp and the Arduino, and all of these devices are showing how just how cheap microprocessors can be. Within your lifetime, that same microprocessor Wi-Fi combination will cost 3 cents. Now, when that microprocessor combination costs 3 cents, it will make sense to put it in a lot of things that we don't put microprocessors and connectivity in today. Now, another feature that's going to cause this is an idea that Mark Andreessen came up with. Mark Andreessen is the guy that decided that it would be really cool if you could put images in HTML, and invented what we think of as the web. Of course, Tim Berners-Lee invented the idea. It wasn't very popular until Mark Andreessen put images on it, and then it became wildly popular. He was working at the National Supercomputer Agency in Illinois, developed the Mosaic browser, went on to found Netscape. He wrote an article in Wall Street Journal probably 2-3 months ago about why software is eating the world. Okay? And if you think about it, software is in almost everything we do. Even industries that are not information technology centric still have a very large software component, and that's only going to get better. Mark Andreessen says, we are in the middle of a dramatic and broad technological and economic shift in which software companies are poised to take over large swaths of the economy. So that's another factor that's driving this. All of this comes together to what people are talking about as the Internet of Things. Putting things online. Now, we probably all, everybody in this room probably has some device that's connected to the Internet, even if it's just your phone. But you probably have things that aren't your phone that are connected. I have probably about a dozen. I have a Withing scale, which is connected to the Internet, so that when I take my weight, it automatically gets saved. I have a Fitbit, or at least I did until it went through the wash. I have a radiostat thermostat, which is a Wi-Fi thermostat you can buy for about $100 at Home Depot. I've got Hue lights, which essentially this is a product from Philips where every light bulb is individually addressable on the network. So you can control the light bulbs individually. I have an Insteon controller, which allows me to interact with Insteon devices like switches and outlets and other things and control them online. I've probably got about a dozen things that are connected and somehow interacting with the web. That's going to get even, we're going to see even more things connected to the Internet. When a microprocessor costs 3 cents, it might make sense for your kitchen table to have a microprocessor in it. I might say, well, what would my kitchen table do with a microprocessor? Well, 10 years ago, you would have asked the same thing about your bathroom scale. The point is that when we add connectivity to things, they become more valuable. A Withing scale costs about $120. A regular bathroom scale with a digital display costs about $40. So why does Withings make connected scales? Because people obviously are willing to pay $120 for a connected scale when you're only willing to pay $40 for one that's not connected. Same thing's going to be true of almost everything in your life. Your kitchen table, your couch, the chairs, every one of these chairs could have a microprocessor in it. Now you might say, that's silly, but use your car as an example. Your car probably has around 30 microprocessors in it, regardless of where it sits on the, whether it's an economy car or a luxury car. If your car has electric windows or electric locks, every door in your car has a microprocessor that is connected via a network, because that's a lot cheaper than running bundles of wires to mechanical actuators inside the door. So think about a car and how everything is connected there. What might we want to do in our homes? So this change, this idea of everything having microprocessors in it, and not just microprocessors, but microprocessors that are connected to the Internet, is going to lead to a completely new computing experience, one that is immersive. In other words, we are going to be inside the computers rather than being in front of the computers. Computing is going to be everywhere, and it's going to change how we interact with it. Now, to understand how that's going to change how we interact with all of these computers, you have to think about where we're at right now and why it won't scale. I mentioned that I have about a dozen things that are somehow connected to the Internet. Now, every one of those manufacturers decided to build their product in a particular way following a particular model, the same model. And that model is they build hardware, they build some cloud service that goes with it, and they develop an iPhone app. And if they have some extra time, they develop an Android app too. Now, think about what that means. I've got a dozen connected things, which means that I have a dozen different services that I've signed up for, and I have a dozen different apps on my phone. And if I want my Insteon lights and my Hue lights to both come on when I come into the room, I have to like go to my iPhone and launch the Hue app, and then I have to launch the Insteon app. Do you really believe when you have 1,000 connected things in your life, and you will, that you're going to have 1,000 apps on your phone? That you're going to sign up for 1,000 cloud services? I mean, if this future world entails humans being the connection point between all of these siloed, connected things, it will never happen. And so it won't. What will happen is something is going to come along to tie all of these things together. Probably multiple somethings, and that's what's going to force a lot of this change in how we're going to see computing. Now, another problem that we have, suppose that I have an electric car. I don't, although I'd like one. And suppose I have an air conditioner, and that my utility company charges a surcharge when I go over a certain amount of usage in any given period of time. What I want is my air conditioner and my car to negotiate charging times so that they can get me the cheapest price on electric power. Now, in today's world, the way we would solve that is we would buy our car and our air conditioner from Apple because they're the only people who could make it work. But that's not how the future is going to be. In fact, it's probably not even going to be that we have to buy an LG refrigerator because we happen to have bought a Toyota car. I mean, we're going to have something that is more flexible than that. What we need are any-to-any connections. And we can't build any-to-any connections on a foundation of one-to-one business relationships. Now, we know how to build any-to-any connections. Any-to-any connections are built using protocols. We'll talk about that in a minute. Now, the problem is it's bigger than just the Internet of Things. Because if you think about everything being connected and you wanting to connect to those things, you need to have connections too. You need to be on the Internet, not just when you happen to pull up your phone or sit in front of your laptop. You need to be on the Internet all the time, even when you're sleeping. Now, you're probably not going to do that consciously. What you're probably going to have is some surrogate that is on the Internet for you and managing your suite of devices and all the connections you have to businesses and places and things. I mean, what do we do when the bus stop gets microprocessors in it? You're going to need connections to the bus stop. It's going to have a presence there. So it's not just that all the things are going to be on the Internet. It's that everything is going to be on the Internet. You, every organization you deal with, every place you go, everything you interact with is going to be online, and you're going to need a way to connect and interact with it. So what's this going to look like? What will its architecture be? I maintain that it's going to be vastly different than what we see today. Now, I gave you part of the reason for that in the sense that just the user experience won't work the way we manage the user experience today. So I don't think it's going to be like the current web. I don't think it's going to be like mobile. I think mobile devices are going to be fungible. That is, we're not really going to care which device we pick up. We're going to be able to walk into a room, pick up whatever device happens to be there, and it will be ours for as long as we're holding it and using it. We'll put it down, we'll walk away, just like pencils and pens are today. Well, you don't think about having a special pen that you carry around with you all the time. At least most people don't, right? You just use whatever pen happens to be there. That's the way devices are going to be as well. They're going to be fungible, just like pens and pencils. So it's not going to be like the world of mobile. It's not going to be like a place. And what I mean by that is, if you think about the World Wide Web, the way we think about the web is with a location analogy. We talk about going to websites. Websites have addresses. We think of them in terms of location. But that's not what the future is going to be like. So when we have connections everywhere, when everything is connected, we're going to have connections to all of the things we own, but we're also going to have connections to things we don't own. So like I said, when we're going to walk in and pick out whatever device happens to be handy, when I sit down in the chair, it's going to automatically conform to the body style I have and how I like to be comfortable when I'm sitting in a theater or a classroom. You students can wait for that, right? Being comfortable in a classroom chair will be quite a technological advance. The point is, I don't own the chair in the varsity theater. I'm only going to be sitting in it for an hour. But it's going to be mine for that hour, and I'm going to have to be able to connect to it, control it, and then walk away, and the next person that sits in it is going to have to connect to it and control it. So these connections are going to be permanent in some cases. Right? Hopefully the connection to your spouse is permanent, and you will have a connection to your spouse. The connection to some things is going to be transitory. For example, experimenting with this idea, last semester, or last year, I created a cloud for my class, CS462, and I created clouds for my TAs. And my TAs had connections to the cloud for the class. Now, we didn't create clouds for all the students, but we could have. But the point is, CS462 as a concept in any given term is transitory. It comes and goes. The connections that are to it are transitory. But it's longer lived than my connection to the chair in the varsity theater. So we're going to have to accommodate all these different styles of connections. Now, the way we deal with these problems usually is with protocols. If you think about what a protocol does, a protocol is a way of interacting. It says, when you do X, I will do Y. And if I do Y, you're going to do Z. That's essentially what a protocol is. And we deal with protocols all day long, every day. When you walk up to a door and you ring the doorbell, you are engaging in a protocol, one that you learned as a child, which says when you approach a door, you don't enter it unless it happens to be yours. If there's a doorbell, you ring it, and your expectation is that the person on the other side of the door will answer it. But that's a protocol. Humans develop protocols for everything. We have protocols all the time. This is how society works. Now, in computers, we have protocols too, but they're much less flexible than that, and they take years and years and years to develop. We're going to have systems that develop protocols much more quickly. Now, I think the answer to that is probably in semantics and more generalized semantic systems. So Tim Berners-Lee was right 10 years ago when he started talking about semantics. None of us really understood what he was saying, though. But it's starting to become apparent why that matters. So if we have all of these things connected, and they're all connected to each other, what we end up with is a decentralized network. Now, we have some experience with decentralized networks. The internet is a decentralized network. It's probably the largest decentralized thing that man has ever built. However, it's going to get bigger, and we're going to have to deal with some of the peculiarities that decentralization causes. Humans don't like decentralization mostly. We like centralized things because we like the structure and control that a hierarchy gives us. But if you think about how nature does things, nature mixes hierarchy and network. Your body is a decentralized system of trillions of cells, but it also has hierarchies within it, systems, organs, etc., that help govern how it works. If you think about the overall ecology, right, it is a completely decentralized system with almost no centralized authority whatsoever, other than the structure that a common biological process gives everything. So nature gives us a model for how we can build large decentralized things. Now, fortunately, our own society does as well. Like I said, we have protocols all over, things like ringing the doorbell. You participate in a vast decentralized system every day when you drive your car. It has some governance, but mostly you decide where your car is going to go, when it's going to go there, and as long as you follow certain rules, it all works out. Well, as long as everybody follows certain rules, right? It mostly works out. And it's fairly flexible, as anyone who's driven in a third world country can attest to. The point is that we have built decentralized systems, even though we don't like them. We like hierarchical command and control systems. We have to get much more comfortable with large decentralized systems. Now, this decentralized system, fortunately for us, has a model. And that is that the model is going to be the real world. When we build this large decentralized system that has everything, every place, every organization, and every person in it, the model is going to be the physical world. In other words, if we built a model of this room, we would know that it is a room, that it has so many chairs, that they're arrayed in certain positions. All of those things would be useful information in building a virtual model of this room, so that all of the things can start to connect to each other and interact with each other. It might be important to know that two chairs are next to each other, for example, or how the lighting and heating systems interrelate. Those are all things that will have to be in these models of how the world is situated. Now, we won't do all this by hand. We'll have to have automation, which helps us automate these things and builds them. We're going to need to be able to create this system on top of existing systems. But these nodes, all of these nodes will be networked to each other. They'll have connections to each other without necessarily being on systems which are all connected to each other, at least not in a specific way. So if I'm hosting some of my nodes in one place and some of my nodes in another place, they won't have to have, those two places won't have to have a business relationship. That's an important idea. And it's also important that we be able to self-host things, because a lot of things will self-host. Your phone, for example, is perfectly capable of hosting its own virtual presence because it's connected, it has a processor, and so on. These nodes are going to have certain properties, I believe. I don't believe that all of these nodes will be the same, but they will have certain properties in common. The most important property is that they will have a globally unique identifier. Every node will be unique, and that will allow us not only to address it, but also for us to tell one node from another. I heard somebody say the other day that one of the interesting things about the physical world is that the Pauli exclusion principle ensures that any two particles have a unique identity, right? Consequently, they can't be in the same place at the same time. Well, you think about that, you say, well, what does it have to do with these nodes? Well, they may not be in a physical place, but they will be in a virtual place, and we need to make sure that they're not in the same virtual place at the same time, right? That we can tell them apart, that we can tell that this notebook is different than that notebook. Now, we're used to large, expensive things having a serial number and having a unique identity. We're not necessarily used to everything having a unique identity, but it will. I believe that these nodes will also be persistent. That is, that they will exist independent of the existence of other things. So when a node gets created for this chair, that node will likely follow that chair throughout its life. It will get created when the chair is manufactured. It will follow it through the transportation and logistics system. When it is installed here, that node will be connected to other things. And finally, when the chair is taken out, either to be recycled or to be reused somewhere else, its node will go with it. So every physical thing will also have a virtual thing that is persistently connected to it. It will have persistent storage. You'll be able to ask that chair where it was made, when it was made, who sat in it. You know, there's privacy implications there, but it might know who sat in it over the years. It'd be interesting questions, right? These are the things that people have made stories up for years. I mean, think about Hans Christian Andersen, you know, and stories about talking chairs. Well, this is becoming a reality. The chairs will talk. These nodes will have to be programmable. That chair may run programs. It may run certain programs when it's installed here, and it may run different programs when it's being manufactured to aid in its manufacture, all of these things. And they will need to be interactive, and what I mean by that is not necessarily that we will always interact with them, because we may not directly interact with everything, but they will need to interact with each other, with their manufacturer, with their maintainer, all of those connections that a thing has. Things have relationships, even though we don't typically think of it that way. And those relationships will need to be reflected, and those organizations, people, other things will need to be able to interact with the thing. Now, how's this going to change your life? I think that there are some positive aspects to this. Probably the most interesting, at least for me, is that the world and everything in it will become programmable and malleable. Things will start to be much more flexible, because rather than just being a dumb physical thing, it will have software in it. And software makes things malleable because we can program them. As I said before, I think a different way that this affects our lives is that computing will become ambient. There will be an ecology of computation, and we will live in that ecology of computation. Some of us more comfortably than others. Right? There will be many people who will be very uncomfortable with this ecology of computing, but we will be in it. Rather than the data being in the device, the computation will be everywhere. It'll just be around us. But I also believe that what that means is that computing experiences will have the opportunity to become more natural. Rather than us trying to accommodate some little device with a desktop metaphor or a paper metaphor or whatever metaphor we're using to structure the user experience. The user experience will be appropriate for each device. That's interesting. So I have my iPad has decided to tell me that there is an event coming up, and you're not seeing it, but I am, but it won't close while I'm in presentation mode. So this doesn't have a lot of context, right? It doesn't know I'm in presentation mode. It probably ought to. Anyway, the more natural and personal interaction that we'll have with things will provide us a way of computing that doesn't feel like computing. It won't feel like grabbing a mouse and typing on a keyboard or even touching a screen. It'll feel like living. If it doesn't feel like living, then I think we've failed. It'll be a different kind of living. It'll be enhanced in certain ways, but it will be like living. Now, what will be negative about this? This is interesting. Hold on, I can't even, it won't even let me advance this slide. So let me, there we go. Okay. So there's some negative consequences around this too. If there weren't, science fiction authors would be out of a job. So what will reality mean? What will be real and what isn't real? Is the experience that you get reality just because it's the experience that comes in your eyes, even though it happens to be generated by this orchestrated mass of computers that are going to be all around us? Or will we somehow just not even notice? Or will it feel unreal in some ways? A good example to think about right now and how this might play out is think about books. Physical books have largely disappeared, at least in some people's lives. And William Gibson said the future is here, it's just not evenly distributed. So for many people, books have disappeared. They no longer have any physical books. All of their books are on their device or in the cloud. That has certain advantages, but I like books. I have a whole library at home. I like to hold books. Now, I also like to read on my Kindle because it's a better reading experience, frankly, than holding a really heavy book. But I like books. I don't want them to go away. But is there any reason to keep manufacturing them when we'll all have these and be reading them here? Probably not. That's just an example of how reality will change, and will it be as good? Will we like it as well? Another thing that is a possible negative about this world is, as I mentioned, I believe it has to be decentralized. I don't think that you can create a hierarchical command and control structure that will dominate this entire network any more than you could create a hierarchical command and control structure that would dominate the economy of the Soviet Union. I think those are completely analogous. We can't do either one. So it will be decentralized. There's problems with decentralized networks, at least as far as humans are concerned. They're non-deterministic, right? Your neighbor might back into your car. Now, if it were a complete command and control structure and you were in charge, you wouldn't let your neighbor back into your car. But you're not. He's autonomous. He's an agent. He can act for himself, right? And in that case, your car is going to be acted on. Quote Elder Bednar. Or to paraphrase him, I guess, is more accurate. The point is, decentralized networks are non-deterministic. Things do things of their own volition. And when they do, sometimes we might be negatively affected by that. Are we going to be able to build a world where this non-determinism is acceptable? Well, I mean, we have societies that are non-deterministic, and we largely find them unacceptable in many cases. So the legislature meets and tries to fix it, and usually doesn't. So will it be a utopia or will it be a dystopia? Right. I think it'll probably be somewhere in the middle, like most things in life. There are going to be great things about it. There are going to be things that we hate about it. Just like there are great things about having a whole world full of cars, and there are some awful things about having a world full of cars. It just is. What are our challenges? Well, one challenge is anybody who's worked with computers has probably already gone there. What about security? What about privacy? Will we be able to trust all of these nodes? Right? Will they somehow kill us? Maybe not because they're conscious, but just inadvertently. And because so much becomes computerized, we don't do it right. You know, malicious people or even accidents cause something bad to happen. But certainly within the realm of possibility, we have to be aware of that and be thinking about how we can deal with that. As I mentioned, there is a huge modeling challenge. A trillion node network will model the world. That's a big problem. Right? I don't know how we build models like that. And of course, anybody who's built models at all knows that the model never completely mirrors the thing that it's modeling. It can't in some cases. You have to make choices. How will we make those choices? That's another challenge. Okay. This is Kevin Kelly. He was the founding editor of Wired magazine. He wrote a book called What Technology Wants. And you may not have ever asked yourself that question, what technology wants. But in fact, technology wants things. Now, it doesn't want things in the way that you want things, being conscious and making decisions about what will make you happy. But if you look at the course of history, there is a march of technology, which Kelly argues, and I think convincingly, is inevitable. Technology does what it does. It is going somewhere. And while we might be able to choose particular manifestations of that technology, it's almost impossible for us to choose to not do certain things. You might say, well, we're humans. Of course we can choose to not do certain things. The problem is there's 6 billion of us, and we're all decentralized, and most of us have certain freedoms which allow us to pursue ideas, whether you want those ideas to be pursued or not. And there are certain trajectories in those ideas that lead us towards certain ends. I think that the changes I've described today are inevitable. We will have computers in everything. They will all be connected. There will be this trillion-node network. Our choice is not whether that trillion-node network will exist. Our choice is what form it will take, how we will interact with it, and what we will do to make it more of a utopia and less of a dystopia in the future. So I have some recommended reading for you. The first two are fiction, the last one is nonfiction. Long ago, Kelly mentioned that I was the CTO for a company named IMAL. And we had a meeting with Mark Andreessen, the guy I mentioned earlier, who was the founder of Netscape, inventor of the modern browser. We're sitting in this meeting. The COO, a guy named Joe Ruskowitz, our COO, a guy named Joe Ruskowitz, is talking to Mark Andreessen. And Mark looks at him and he says, "Joe, have you read Snow Crash?" Joe goes, "No, I haven't even heard of it." He says, "Well, then this conversation's over because I don't even know how to explain what I'm going to tell you." And he walked out of the room. That's when I wrote Snow Crash. Snow Crash, if you read it, it was written in the 90s. Neil Stephenson is a fantastic author. It was written in the 90s. It is, now, in 2013, you'll read it, and some of it will feel like it's not even science fiction. It will be so close to reality, you'll go, "Oh, well, that's not very exciting." But there are things in there which are interesting in terms of thinking about this trillion-node network. Rainbow's End is a similar science fiction book about what happens when the entire world is connected and everything has computers in it. Werner Vinge is a CS professor at UCLA. He's written a lot of science fiction books. He's probably best known for the concept of the singularity, which is a whole different 30-minute discussion. But Rainbow's End, there's probably, I found it to be a really interesting book. There's probably 100 pages of plot and 200 pages of description of what a connected world looks like. So if you're interested in a connected world, it's one man's view of how that connected world could play out. And there are some things in it that you're going to go, "Wow, I really don't want to live in that world." In fact, the main protagonist in this story is a guy who wakes up. He is cured, essentially, from Alzheimer's because of technological advances. And he is now finding himself in this new world and having to navigate it. And anyway, there is a plot that's fairly interesting. Trillions is a recent book about trillion-node networks and how they can be built, what they will look like, how they'll change our world. Lucas and Bailey and McManus are at a design studio in Pittsburgh called Maya, which they've done some really great thinking on this. If you want a short version, just go Google Trillions video and watch the one from Maya, M-A-Y-A. But anyway, highly recommend those books. So, trillion-node networks, like I said, I think they're inevitable. They will come. Our question, as I said, is what will we do about them? Everybody in this room deals with technology in some way. That's why you're here. You'll all be part of this world. You have choices to make in what you build that will help build this network. I encourage you to find out about it and to spend some time thinking about how you can incorporate some of these ideas into the work you're doing now so that you can better understand as this comes about. And that's all I have to say, so thank you.
Cool. So I guess while everyone's coming up here, one of the first things I'd like to say, speaking on behalf of the student body, is we hope that those smart